Hey, it's OG Math Mosley. Today we're going to be looking at how to construct a histogram or a dot plot from a given data set. This is a basic thing that we have to do in statistics so we can look at our data and then say things about it. What the distribution looks like, where our values are concentrated at, what the range of the values is, and it's a nice visual representation. All right, so we have two graphing areas set up here. We have our histogram and our dot plot space available here, and I have two sets of the same data. The data set we're going to be using today is representing the miles per gallon in city driving for a sample of 50 cars. All right, so the first thing we're going to do is work on our histogram. The histogram essentially takes ranges of values and tells us how many values in our data set lie within that given range. We sometimes call these ranges bins, and the amount of things in each bin tells us the height of the bar for that range. Our first bin is from 15 to 20. All right, and the important thing is typically with a histogram, the left boundary, like in this case 15, is the first value that goes in that bin, and then the right value, the upper bound, the 20, is the cutoff mark. Usually the cutoff mark is not part of that bin. So this first bin can take all the values 15, 16, 17, 18, and 19, but not 20. 20 will go in the next bar. All right, so for example, we're going to go through and find all the values in here that are 15, 16, 17, 18, or 19. Right, so we'll just go through our numbers and cross them off and count them as we go. All right, so we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, and 19. Okay, we have 19 numbers that are 15 or more, but less than 20. Okay, and that tells us the height of this first bin. That's going to be 19. Right, and so we'll draw that on here as the first bar, going from 15 and up to, but not including 20. Then we'll do the same thing for the next range of values, 20 to 25. So again, remember, we get to include 20 this time, but we do not include 25. Right, so we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19. Did I skip one, or did I skip a number in general? I think I got them all. All right, so we have 20 values that are between 20 but greater than or equal to 20 but less than 25, and that will be the height of the next bar. There we go. All right, and notice that the bars are touching. There is no space between these bars. All right, this is because this is a continuous distribution where one ends, the next one begins. Right, and this is typically the case with quantitative data, which is data that you can find an average of. Right, and then we'll continue this process for the rest of our values. All right, and there we have the histogram. One other step that we should take to make sure that we didn't skip any values or miscount, because there's 50 of them, it's easy to make a mistake, is we're going to add up the height of the different bars that we have here. When we add those up, we should get 50, which means we've accounted for all the data points. All right, and so this is 19 plus 20 is 39. plus 7 is 46, plus 2 is 48, plus 1 is 50. All right, so we have all 50 of our data points accounted for, and this is our histogram. This represents the distribution of the data. It shows us where the values are concentrated. We could easily say, you know, a majority of our data, a majority of the vehicles sampled get between 15 and 25 miles per gallon in the city, right? And there's other things we could say about this once we learn a little bit more about distributions and how to describe them. All right, so next we're going to do the dot plot. Oh, wait, before we move on, a couple of key things that I haven't done yet here, which is labeling what each axis, the horizontal and vertical axis, represent. Down here we should just have essentially our title, right? And this is miles per gallon in city driving, right? And then on the y-axis, right, or the vertical axis, this is what we call the frequency. It is a fancy word for count, how many times this thing happened, right? And so that's how we label these. On the dot plot, we essentially only need to label the horizontal axis, which again will be the miles per gallon in city driving. Right? And that will be the only thing we have to label besides the values on our line. And so now again, a key difference here that we're going to see right away is that there is no vertical axis. There's no y-axis in this. It is just the horizontal axis. And this is because we use dots and the number of dots on each value to represent the height of each value. So there's no need for a frequency or a y-axis. All right. The other thing to point out is that the spacing between our hash marks, between the histogram and the dot plot, is even, right? It's equivalent. There's a range of 5 units on our histogram, 15 to 20, 20 to 25, 25 to 30. Even though like we didn't use 35 to 40, we still labeled it, we left it empty. Same thing happens on the dot plot. We don't just use the values that show up in our data set. We need to account for all possible values because they're all possible. Do we use them all? No, but they need to be accounted for and we cannot skip them. Right? And it is always the correct thing to do to have an even spacing, all right, between your hash marks representing the same distance all the way through your graph. All right, so now we'll get to our dot plot here, and we're going to use kind of the same process. We're going to start at 15, count up how many things are 15, then 16, then 17. We have to do each value this time, so it will be a little more time consuming, which then leads to deciding what the best graph of your data is. Typically with a lot of data points, you're not going to want to use a dot plot, at least not by hand. You might use a program to do it for you, which saves time. You just have to enter the data and it'll pop it out. But if you're doing it by hand, the histogram is definitely the way to go for larger data sets, such as one with 50. All right, so here we go. We're going to start here, and we'll start with 15. All right, and 15 is the lowest value we have in our data set, and that's why we're starting at 15 on both graphs. We do not need to start at 0 because we don't have anything in that value range. Right, 15 is the lowest. So when doing a histogram or dot plot, we can start with the lowest value as the lowest value on our graph. All right, and so we have 1 and 2 values at 15. So we're going to mark those as little dots. All right, and we'll go to 16 and count up all those. We have 1, 2, 3. 4. I think that's it. All right, so 1, 2, 3, and 4. And we'll go to 17. 1, 2, 3, 4, 4, 18, 2, 3, 4, 5, 6. Right. And we'll continue this process to get through all of our data. All right, and there we have it. That is our dot plot. Again, it basically shows the same data that we got from the histogram. It's a little bit more detailed. We know exactly how many of each number there is by looking at the dot plot. But again, it basically tells us the same thing, that most of the data is between 15 and 25. We've got a couple of values that are kind of like way larger than the rest of them, which we'll later learn could possibly be outliers. And we'll learn more about how to describe this later on. Right, if you do have any questions, please let me know. Otherwise, we will see you all next time.